afternoon to you all, and welcome to this webinar, Lifting the Veil, How AI Thinks, presented by Monash Tech Talks. I'm Andrew Patterson, and I'm joining you today from Auckland, New Zealand, where I'm a freelance business and technology writer, and I'm very pleased to have this opportunity to facilitate today's panel discussion, perhaps invoking the Anzac spirit we acknowledge this week. I know we have people joining us from across Australia and indeed around the world, so perhaps you might like to drop into the chat where exactly you are joining us from today so we can see the extent of our global reach. Can I begin by respectfully acknowledging the Wurundjeri and Bunurong peoples of the Kulin Nation and the traditional owners and custodians of the land on which we are meeting today, and pay respects to their elders past, present and emerging. I also acknowledge the traditional custodians of the various lands on which we are all located today and the Aboriginal and Torres Strait Islander people participating in this event. Can I acknowledge here in New Zealand, Ngāti Whātua Ōrākei, the local Māori iwi, who are the traditional owners of the land in Auckland, where I am today. And now it's my pleasure to introduce our three panelists who are joining us today. I'll briefly introduce each of them by name and title, and then give them a minute or so to provide just a very brief snapshot of their backgrounds and their particular research interests. So first up, Dr. Moore Verrid, co-director Human-Centered AI Lab at the Faculty of Information Technology. Welcome, Moore. Over to you.
Thank you. It's great to be here. So my interests, research interests lie in the intersection between AI and the social and cognitive science. And my main research disciplines are explainable AI, human-centered explainable AI, as you mentioned, as well as intention recognition. And I believe that only by collaborating and coming together from the social, cognitive sciences and medicine with AI, will we actually be able to make a difference and create AI that has a powerful impact on human lives.
Thanks, Moore. We look forward to picking up on some of those themes in our discussion. Next up, Dr. Cecile Paris, who is Chief Research Scientist, Data 61 at CSIRO. Cecile, welcome to you.
Thank you, Andrew. And thank you for inviting me to this panel. It's great to be here. So as Andrew said, I'm a Chief Research Scientist at CSIRO, which is the Australian National Science Agency. I joined CSIRO about 25 years ago after working in the US and the UK. Now, my own background is in natural language processing and user modeling, and that's how I came to explainability, producing explanation in language, since this is my background. I'm interested, like Moore, I'm very interested in how we bring different disciplines together. And in fact, I'm very happy to say that I'm collaborating with Moore in co-supervising a PhD student, because I think it's really, really important. And I certainly second Moore's statement that we need those different disciplines to come together to really have an impact. And I just mentioned as well, so beside my interest in natural language processing, user modeling, and explainability, I'm currently leading a new research program at CSIRO, which is called Collaborative Intelligence, where we're really looking at how human and machine work together. And I think explanation is going to be a large part of that. Thank you.
Great, thanks, Cecile. And finally, Dr. Michael Weibra, who's Senior Lecturer, Human-Centered Computing at the Faculty of Information Technology. Michael, welcome.
Thanks, Andrew. Appreciate the invitation to be here. So I'm a human-centered computing person. I work on problems related to interface design and dashboards and other usability issues. I kind of fell into explainable AI through being a consumer of some of this AI technology and using it for my work. So I started out working on tools to help humans lay out diagrams and using constraint solvers behind the scenes, basically a mathematical program that sits behind and updates things, and realized quickly that there's a problem where users can't understand why things are happening. So worked on creating visual representations to explain this behavior. And then more recently, over the last 5 years, I've been working on layout and optimization projects with Woodside Energy. And here the problem is about determining positions for equipment and pipes in process plant layout, basically the design of liquefied natural gas production plants, which is something that takes teams of engineers many months or even years to do. And we're looking at using, again, AI technology, optimization technology to speed up that process and provide them with solutions that can act as a starting point. And this is very much human in the loop optimization. There's a need to explain the solutions. You can't just give someone a solution. They need to see a visual representation. They need to understand the cost function that drives that solution and the components of it. And then if it's contrary to their expectations, there's a need for them to be able to explore why that is. So that's kind of the work I've been doing in this space.
Fantastic. Thanks, Michael. We've allowed around 40 minutes for a broad-ranging discussion with the panel, where I'll be putting a series of questions to them on the topic of explainable AI. So let's kick off. Explainable AI, or XAI for short, is a term we're hearing more and more these days. In this talk, we want to lift the veil, as it were, and take you behind the scenes when it comes to developing an AI society we can truly rely on, and in particular consider how XAI is created and implemented, consider some real-life applications, both now and in the future, and examine the intersect that exists with other disciplines as well. Modern AI systems are increasingly capable of tackling real-world problems, yet the black box nature of some AI systems giving results without a reason is hindering the mass adoption of AI. According to an annual survey of CEOs by PwC, 82% of them agree that for AI-based decisions to be trusted, they need to be explainable. As AI becomes ever more an integral part of our modern world, we need to understand why and how it makes predictions and decisions. I appreciate we do have a range of expertise in the audience, from those who are fairly expert on this topic through to those who are not so familiar with explainable AI. So we'll begin with a brief overview and then get into more depth as we go along. So let's begin with the obvious question to provide some context for this discussion, which I might pass to you, Michael, to kick us off. Can you briefly outline what explainable AI is, how it differs from what we might term regular AI, and most importantly, why it is important?
Sure. Thanks, Andrew. So look, it's worth starting out and saying that AI is a broad range of technologies. It's an umbrella term that covers lots of different things. And these technologies have existed for a long time, upwards of 30 years in some cases. They're not super new. And some of these, what we term as AI, will be things like intelligent decision systems that take a process that a human would have done and automate it and allow it to be done more quickly. There's some of these are techniques like regression models, where you're basically getting some data and fitting a curve, and you end up with a formula, and you can use that formula for a prediction. And in that case, these techniques tend to be quite explainable, in the sense that you end up with a formula that directly gives you an output from some input values. And then we get down to the technologies like deep neural networks that are typically not considered to be explainable, in the sense that we as humans are able to train them, give them some set of data, and get predictions out of them, but not really understand what is involved. The weights that are used internally are learnt, and we don't have the visibility into what's going on, what the individual steps of that process or algorithm are to reach that output. And that's this black box nature that you talk about. And I mean, it's worth for a moment just talking about some of the different applications of these that people have probably seen. So if you've got mobile smartphones, typically you've probably made use of things like speech to text, where You speak to your device and get text back to you. Things like translation with Google Translate, where you can be overseas and point your phone at a menu and see what the items on that menu are translated to English, or image classification, where your photo library on Android or iOS, you can type the word dog into it and get a collection of photos that contain dogs, and sometimes there will be misclassification. So like, this is sort of the kind of applications of AI that maybe don't need to be so explainable. You just get some results, and if they work, you're happy with them. If they don't work, you go, oh, well, it's better than I could do myself. I'm not going to go through and look at all 15,000 photos in my photo library to find the dogs. So I'm happy if it finds 90% of them or 80% of them. And then there are other cases where we would care about explainability, like if we ask for a home loan and we're denied or given a lower home loan amount than we would wish for, and we want to know why that is. And increasingly, some of these decisions that would have been made by humans are being made by AI systems, and this is where explainability comes in.
Let's just dig into this idea of explainability a little bit more for a moment. So what does it mean to actually explain AI models in terms of existing definitions? Because obviously you're going to have different explanations for different stakeholders, right?
For sure. In this kind of domain, there will be people like the machine learning experts who are creating the algorithms. They themselves want to debug them and check that they're right. So they care about explainability, because that's a way that you can actually prove to yourself things are working the way they do. If things are being used for decision making, let's say for image classification, rather than detecting dogs in your photo library, it's looking at aerial photography of military activity, and you want to detect whether something is concerning, and then you're making decisions about sending troops in somewhere based on that, or doing missile strikes or whatever. Those kind of things, you don't want to do them. You want to be able to justify why you're doing that, and as a result, you need explainability. And the explainability, as you say, Andrew, needs to be at different levels. If it's just what pixels in this image have contributed to this image being recognized as a dog, that's very different than the more serious applications.
Moore, can I bring you in here? Can you explain why we need human-centered I guess this concept of human-centered explainable AI, particularly linking it to the social sciences versus vision. I guess also this importance of it being simply beyond for data scientists and drawing on other disciplines as well too. Can you just give us some color around that topic?
Yes, I'm happy to. Well, AI it's all around us now. I guess it's prevalent in almost all aspects of our lives. We have personal assistants that use it. We have recommendation systems like Netflix and Facebook and social media, and we encounter these every day. And that means that these explanations that we're now aiming to create, they need to be aimed at explaining to everyday users, right? Not just the domain experts, right? We have people with various capabilities, backgrounds, ages, and they all need to be able to understand why they've gotten a certain output. Now, in order to explain to people, you really need to understand how people think and how people best understand. For example, if you have an explanation that says you should do this because the outcome has a likelihood of 0.75637, well, that's not necessarily helpful. People won't necessarily understand what that means, in which context to view it. In fact, it just might make them resent or distrust the algorithm suggestions, because people don't understand and a lot of times don't like numbers. So to know exactly how people do understand, we need to take a multidisciplinary approach. We need to rely on the social and the cognitive sciences. For example, while people don't like numbers in general, there's been research that's shown that if these numbers are used to contrast between two options, then they're actually beneficial. So, okay, we need to provide a counterfactual example. And then there's ways to choose that counterfactual example that helps people understand. Another example, people will prefer a short explanation that explains the most questions and the most variables rather than a long, detailed explanation that explains everything. And this is a kind of a counterintuitive explanation, but if you provide a really long, detailed explanation that gives you all of the reasons why an outcome came about, people might actually distrust it even more. So that means that computer scientists and AI researchers now, they can't afford to work as an isolated team anymore, right? We have to collaborate and we have to consider the end user.
Thanks for that. Cecile, can you give us some specific examples of applications where explainable AI is being used? I guess Michael has alluded to perhaps, and more some of the more obvious ones, but maybe some of the ones that might surprise us a little bit that we're not aware of.
So yes, thank you, Andrew. And yes, Michael has already alluded to some of them. And he's also mentioned that this is not a new area, really. It's new that we talk a lot about it. But actually, my first job was looking at explanation for expert systems, which back then was the AI technique of the day. And we were looking at how do you explain expert system behavior. And we were looking at a medical domain. So that's one example. And I know Michael mentioned that and more as well. Medical domain is one big case where you would want an explanation. If a computer decides, in order to assist decision making, it's not making a decision, it's assisting. And if the system says that has reached a specific diagnosis, then you may want to know why this diagnosis, and importantly, why not another one? Mm-hmm. And that also not only is there a use for explanation here, but that also relates to something more said. And I think you mentioned, Michael and Andrew as well, the different stakeholders. So when the doctor comes up, when the system is being used by the doctor and comes up with a diagnosis, the explanation for the doctor is going to be different than for the end user, because they're going to need different type of details. Otherwise, as a user, I will not understand if the system gives me very technical things. So the stakeholder is really, really important, which again reinforces what more talked about, the human-centered explanation for AI system. I'll give another example, which is actually in the scientist world. Michael mentioned the image analysis, which, if it's for the end user like me, yeah, I'm perfectly happy with a system recognizing, half a dozen pictures. That's probably all I need anyway. I don't need to look at everything. But if you look at a scientist, like a biologist, and we actually have such a project here, where they are classifying a specimen in a collection. So they are dealing with millions of specimens. Clearly, they cannot do it one by one themselves. So they are trying to look at a system. And sometimes they do need to understand, why did the system reach a conclusion as opposed to another one? Why does it think it's it's species A versus species B? And they need to understand that. So again, it have to be in fairly technical term, but even in that domain, which is image recognition, but it's specifically for a purpose of classifying various insects, plants, etc. But I will also mention a final case, which is a bit different, and I think Michael alluded to it, which is debugging. So sometimes you also want to debug your system. It's really important as somebody who develops system, and there the explanation is also important. Again, being different stakeholder, different level of details is provided, but you will need to know before you deploy a system, yes, are you happy that, given what you looked at it, how it's explained, its behavior, its data, etc., you think the system is appropriate? And I'll leave it at that.
Thanks, Cecile. I want to break down some of the key elements involved in explainable AI, because as our panelists have all alluded to, there are a number of really important facets of this in order to make it work. And Michael, let's kick off with accuracy, which obviously is a really key element in the use of AI in various applications. Can you explain how XAI deals with accuracy? And I know that's very difficult. I'm sure you could deliver a good 3-hour lecture on that, but just a bit of an overview.
Sure, thanks, Andrew. And I think one of the things to first point out about accuracy is whether we as humans can determine whether the prediction of the AI is actually accurate or not, okay? In some situations, like the classification of the images that Cecile was just talking about, or the classification of dogs in our photo library, we can look at it as a human and say, yes, that's right, no, that's wrong. But there's some machine learning examples like the chess playing, machine learning, that they behave in ways that are unexpected to us. And at first, even our grandmasters look at these moves and don't understand them. And in fact, like some of the chess playing AI has led to changes in human behavior about the best approaches to play. So the first aspect of this is first, can we actually determine if something is accurate? In terms of training models, we train them based on data sets. And when we're talking about sort of neural networks and things like that, and we talk about terms like sensitivity, which is the rate at which a model accurately predicts true positives. So let's use the example that Cecile was mentioning of medical diagnoses, right? If I have a machine learning classification, look at something, MRIs, other scans or something, and determine whether I have a particular condition, the sensitivity rate is the rate at which the algorithm detects correctly when I have a particular condition. Then we talk about something, and obviously you want that to be high. Something like specificity is the rate at which it determines correctly the people who don't have it. And obviously you want that to be as high as possible too. You don't want to misdiagnose people and say they have a disease when they don't. That's obviously a bad outcome. So typically you want the highest sensitivity you can have while not sacrificing this specificity. So you train it on that, but then there's a question of when you give it actual data, how does it perform? Because one of the dangers is you train it on one set of data and that's not completely representative of the places it's actually used, especially if it's going to be used for the next 10 years or something like that. So what are people doing to understand accuracy? They're feeding in known cases and looking at how the machine learning algorithm will predict from it. And sometimes they're doing things like more mentioned counterfactuals, which is giving an algorithm a particular case for something you wouldn't expect it to classify in a particular way, and looking for situations when it does that against your will, and understanding why that happens. Yeah.
Is it simply a case that the more you train the algorithm, the more it will get it right? So, and how does the auditability of these outcomes occur to maintain the accuracy?
They can get better if the data you're giving it is good, right? It's very much a question of, if you train things on the wrong data, you can very much get the wrong outcomes. And one of the tricks is understanding both the data you're training it on, but then the features within the data that the algorithm is actually using for prediction, which may not always be the ones that you expect. And I guess we'll probably touch on topics like bias and things like that. And that very much comes into play there.
Okay, let's come back to that. What about the issue of traceability? For example, by limiting the way decisions can be made and setting up a narrower scope for machine learning rules and features. How does that work in practice?
Okay, well, up until now, when you wanted to develop a program that does something, you had requirements and you had specifications as input. And then you coded a set of rules in a programming language like C or C++ or Java. And that told the software what to do in different circumstances, and what not to do. Like if you're a robot navigating an environment, if you reach a wall, scan around you in a certain amount of degrees, and if there's no obstacle, take the path that'll lead you closer to your intended goal. Now, as Michael previously mentioned with machine learning, this functionality is not implemented through kind of rules, but it's often implemented with deep neural networks, DNNs. And the behavior of DNNs is not explicitly coded. It's trained through a large set of training data. And this makes traceability a lot more difficult and all the more important. So traceability is basically the ability to backtrack, right? And this is important so that you know why the algorithm gave you the output that it did. And when you know why, you're able to detect mistakes and you're able to fix them if necessary. With DNNs and machine learning, you need to rethink the traditional traceability as new concepts. And this relates to a question that was raised in the Q&A about how resource intensive it is to convert current AI systems into explainable AI and why we haven't been defaulting to it from the beginning. Well, the short answer is that with regards to DNNs and machine learning, it can be pretty hard. You really need to rethink traditional concepts, right? So in DNNs, factors that could be traced are the network itself, the weights set to specific values, the parameters, epochs, batch size, etc. Now, all of these can help provide insight why a decision was made, although not necessarily in a way that is intuitive to human users. Also, and maybe most importantly, another thing that can be kind of traced, the data. So the behavior of the network is obviously dependent on the data that has been trained with. So instead of which action led to a certain decision, which is what you would have traced in non-DNN algorithms, you now need to consider which training data might have led to a certain decision. And this in itself can be problematic because data is usually derived in some form or another from people. And people are not flawless, they're often biased. So the data will imbibe that bias, but that's another topic.
We'll come on to bias. Just let's touch on trust, because obviously this is also really key to every part of XAI. Many people have a distrust of it, yet to work with AI, they also need to trust it. This is kind of dichotomy. So how is trust managed within an XAI context?
Well, I like this question, and I like it because there's no straight answer. And this is because sometimes people need to trust AI and sometimes they don't. They need to be able to differentiate, I guess, between when they should and shouldn't. Explainable AI is not necessarily about increasing trust, although sometimes it seems to be represented as such. It's about creating the correct amount of trust in people. So this needs to be done through providing explanations that give people transparency, that give people knowledge into the inner workings of the algorithm, so as to allow people to decide when the algorithm is correct and when it's making a mistake. And again, you need to consider the stakeholders and their amount of knowledge in providing this explanation so that they can actually make this decision. And this again emphasizes the need for human-centered explainable AI that is inspired by the social sciences. Some ways of explaining, as we have recently done some work where we explained something and we looked at different types of explanations to explain the output of our algorithm. And we saw that there's one way where people just immediately trust it. And they're saying, oh yeah, that means it's correct. So that's not a good explanation because even when the algorithm provided, by the way, not one we foresaw happening, but if again, and as I mentioned before, when we gave all of the explanations, then people automatically distrusted it because they were overwhelmed. So you really need to find that sweet spot in between giving them just the right amount of information to give them enough knowledge to make a knowledgeable decision. So the question is not about more trust, but the correct amount of trust.
Yeah, that's a good point. I was going to touch on that because interestingly, there's as you've alluded to, there's this whole issue about reverse trust. When you put too much trust in AI, even though it might be apparent the results it's delivering are not correct. I was reading a piece where this was actually conducted in some research, and users fall into the trap of what I understand is called the illusion of explanatory depth, where trust is created where it's not actually worthy. So how do you guard against this? How do you? It's a big issue, isn't it? I can see Cecile nodding there as well too. We'll come to you in a tick, Cecile. But this seems to me to be something that's really at the heart of XAI being able to sort of move into the mainstream, as it were.
So unfortunately, really, this is still an unsolved answer, right? You can't necessarily guard against it. That's why we are researching all these different types of explanations, and we're trying to identify, and this is also very particular to different applications. So what do they need to know about each one? But in general, what we're trying to do, and I think where research is going, is to try to kind of balance between the correct amount of global explanations, which give you general knowledge about the inner workings of the algorithm, and local explanations which pertain to specific examples. So when you're trying to balance between the explanation says, well, usually the algorithm does this and this, and then in this instance it did that, you're giving people knowledge that allows them to kind of get a more firm grasp of what is happening and when it could go wrong, and as to make an informed decision.
Cecile, I'll let you jump in there as well.
Thank you, Andrew. No, I was very much agreeing with what you said, and I think that points out all the challenges that there are. I mean, there's no such thing as we can design one algorithm to do explainable AI for every situation, every stakeholders. We have to take into account all those issues, the different stakeholders, the different application, and under which circumstance is the amount of information going to be appropriate, and what is the correct way to do an explanation to indeed not induce too much trust or not enough trust. So it's a very fine balance, and it's hard to find a one rule fits all. I think, there are lots and lots of challenges there. And that's, part of what everybody is looking at right now. And I think it's really, really important to understand some of those issues. Now, it's also interesting that when we say that, some people don't trust AI, I think there is another question, at least in some of the work I've seen, that people don't actually really know what AI is. So if I go back to the example that Michael mentioned earlier on, people don't necessarily realize, for example, that behind their assistant, which tells them when they're making mistakes, spelling mistake, there is AI behind that, right? And they trust that, or they trust the system which looks at the dog pictures on their library, whatever it might be, or other example like that. But people, or their GPS, they don't necessarily ask an explanation of that. So I think the word AI is so broad, but we also have to make that a little bit more explicit. What are we talking about? What situation are we talking about? There's no one thing as, we trust AI, we don't trust AI. It really depends. And I think we have to keep on remembering that it's not a general statement like that, or we need explainability. It really depends when, and those are big questions, I think.
Michael, is this just a reflection of where AI sits at the moment? I read one study, for instance, that gave an example of, even though the results it was producing were clearly wrong, the operator sort of continued to believe in the AI model, and so you didn't get that sort of human-centered intervention override that you would have expected. What are your thoughts around this area of trust, and will this take care of itself over time as AI continues to develop, or will this be a debate we'll be having in another 10 years as well too?
No, I hope it gets better and things improve in this regard. one point I wanted to add to the things that Moore and Cecile have said is that I think that often an issue in trust is where you get predictions, outcomes, whatever they are, that are different than the expectations, especially where it's something that humans were doing in the past. And that's one way to deal with this trust issue is saying, oh, that's different than what I would have done in the past. And then it's not always the case that it's the AI that's wrong or the human that's wrong. It can be either, and which leads into this issue of bias as well, where the AI might uncover that the humans have a bias in their decision making, or it might be the other way around, that we discover something is wrong in the AI, the way that it's doing decisions, or it's making decisions on a feature that we wouldn't wish it to use. So I think then it's almost like this needs to be a conversation, a lot of this explainability, right? And as Moore pointed out in the past, it needs to take into account the knowledge of the person whose the explanation is for, and what their background is, and what prior knowledge they have, and what expectations they have. Yeah.
Now, in one of your earlier answers, you touched on bias, because let's pick up on that now. That this is possibly an area of AI that's had a lot of coverage in the media and so forth around the way it's been biased, particularly in terms of loan applications and those sorts of things, biased against particular postcodes or ethnicities and so forth. Can you talk a little bit about bias and in models and ways and steps that are being taken to reduce bias?
Sure, absolutely. So I mean, the issue here is that when you've got machine learning that's doing predictions, it's trained on past data. And that means if we're talking about something like loans, then it might be past loan applications that had been issued for people in particular postcodes, or for people with particular ethnicities, or things like that. So, I mean, like you alluded to there, Andrew, about sort of cases in popular media about things like this. Like one example fairly recently was Apple's credit card, and one of the original founders of Apple, Steve Wozniak, saying that the credit limit that he was offered was 10 times that of his wife when they share all their assets and accounts, right? And you have to and you have to ask, why was that the case? And there's other classic examples that have got a lot of coverage, like cases of things like judges, a system in the US, which is called Compass, which is used for decisions about reoffenders, risk of reoffending, and offenders' risk of reoffending. And they found that they were incorrectly labeling Black defendants as high risk at twice the rate of white defendants. And when it was looked into this, a lot of it is based on the underlying judges' decisions that we used. So in a case like this, it might be something like the data itself is flawed. Like we have an assumption that it's good data to begin with and worth training on, but then there's issues with it that are unpalatable or undesirable. One way of addressing this in algorithms is to understand which features are being used for prediction and remove them from the training data. So, if we're talking about gender or ethnicity or something else that we consider shouldn't matter and doesn't matter, to remove this from the training data, train the model without that information, but with all the other information, and use the results of that. And then in terms of just testing for this, you can also do things where you take a prediction that comes out of it and you vary one of these features like ethnicity and change it to something else and see, do you get the same result? And if you get a very different result and that's unexpected, you wouldn't want that or expect it, then that there's issues where the model is determining things based on that information.
Yeah, I'd just like to add, if that's okay.
Sure.
So I completely agree. And I just wanted to mention that it's really, really even hard to find those features which do imbibe that, unperceived bias. Because, for example, the Compass example that Michael so correctly brought up, They don't have gender, but they have address. And because people necessarily sometimes reside in the same area of similar cultural background and ethnicity, then this, relatively innocent parameter imbibed that bias. And it's really, really hard to detect. And that is why the testing is really so important on all parameters.
So this brings up, I guess, the obvious question around regulatory oversight, because clearly there's a lot at stake here. And I know some of these areas are now are having and will have regulatory oversight in the future. Cecile, what are some of the issues that are being considered where AI models are being subject to audit in your experience?
So we've already heard some from both Michael and Mo, issues of traceability, issues of where does the model come from, the bias. So clearly, one of the things that people have to consider, especially when there's going to be an audit, is where the data comes from, the data on which the models were trained. Where does that come from? How they were obtained. So sometimes people talk about that as traceability, sometimes as transparency of a provenance. Where does that come from? Is there a bias in this data? Either can actually see it or induced, like the one Mo just talked about, that sure, you're not bringing the social economics feature, but it's represented by the postcode where people are. So sometimes you have to be careful about that. How representative is your data of the whole data set you're trying to represent? So you actually have to think actively about that. And of course, privacy issue. The way you obtain the data, was that obtained in a way that is in accordance to all the privacy and legal issues in wherever the country or wherever you're operating? How was the model itself built? I mean, there are lots of different ways to build a model. Did you use one technique versus another one? Why? Can you justify? Can you trace? Can you provide transparency around that? So there are lots of questions like that, including so that was about the model, the data, but you can ask questions about the overall AI project. So there are, in fact, frameworks now being proposed in various jurisdictions. So for example, in New South Wales, there is an AI assurance framework, and I'm just going to give you some of the questions that are being asked. And this is that, in effect, people have to answer those questions. So is the AI system likely to restrict human rights? If so, is any such restriction publicly justifiable? Where possible trade-off between different principles and rights ascertained, documented, and evaluated, which also touches back to what I said before, is which method did you use? What did you do? Where were the trades-off? Does the AI system suggest actions or decisions to make or outline choices for human users? Could the AI system inadvertently impact humans' autonomy by influencing or obstructing their decision-making? Did you evaluate whether the AI system should inform users that its output, content, recommendation, or results arise from an algorithmic decision? Those are clear questions. I mean, I'm just giving a summary of what's in there, but those are clear questions that people then have to be able to answer in the regulatory oversight. And there is a similar framework in Europe where one of the questions people ask is essentially the right for explanation. So, are you giving people the opportunity to potentially ask for an explanation of the results? So there are quite a lot of work around those issues that are being undertaken right now in various legislations.
Thanks for that. Michael, do you want to just talk us through a little bit around the accountability, which is, I guess, one other part of the framework I wanted to touch on as well, too, the way that I guess organizations are going to be accountable for these, and I guess circling back to our regulatory framework discussion just before I mentioned about the chat there.
Yeah, I mean, I think it's a bit like Cecile was just saying with these regulatory oversight. There's going to need to be record keeping for decisions and sort of provenance of how decisions were made when there's an AI or an algorithmic element to that that keeps track of it. So yeah, I think that's going to be an important consideration going forwards.
first up, do you have any suggestions of relatively simple open source AI projects? Perhaps, for example, not as advanced as the Open AI repo. So suggestions for relatively simple open source. I'll throw these questions out to the panel, and whoever wants to jump in can feel free to do so.
So I think this question raises something that I think Mike or Cecile, I don't remember who said it, but AI is a very broad term. So it depends on what you're trying to do. Are you doing image analysis? Are you doing natural language understanding? Are you doing speech to text? So there's really lots of open source out there. But you would have to look specifically for a type of application. So I think the question is a bit broad to be answered.
All right. Well,
so
if the question...
I'll add something to this, which is just to say, like, if you're interested in, I'm not a machine learning person, so we'll say it with that caveat first, but if you're interested in machine learning, but also particularly in kind of explainable machine learning, there's a person called Christoph Molnar who's written an open book that's available on GitHub. And it goes through various different techniques that are used, machine learning techniques that are used for different classes of problems, but also talks about where they are or aren't explainable, and is a pretty good kind of starting resource for understanding. And it also touches on, you know, the underlying technologies, so where there are toolkits and things that are available for this, which, I mean, as I understand it, I think it was him starting out on a kind of journey into machine learning and AI and keeping notes on all the things he felt he needed to know, and then sort of sharing that publicly with the community.
Next up, what are the challenges in explaining medical data and current solutions to handling them effectively? I think it would be more difficult compared to text or simple images. Cecile, any thoughts on that one?
Look, I think all data is difficult to process. I mean, you said, you know, maybe as different from text or something. Text is very hard to process too. It's huge amount of ambiguity and all kind of different things. So I think all data is difficult. Now, in explaining medical data, I actually, you know, don't really know very much about medical data, I have to admit. I think I think the question is more explaining the reasoning of a system, and also explaining again what the system was based on, the data at the beginning. I don't know that medical data in particular has specific challenges, but again, I don't know. I haven't worked with medical data myself. I did way in the back, but it was about explaining an expert system dealing with medical data. So it was really more explaining the reasoning. So I think the challenges of explaining where the data comes from, what data has been trained on, and the reasoning of a system, that's where really the heart of the matter is. And any data, I think, is going to be difficult. But Michael wants to jump in. Michael, do you have any?
I'll just jump in and say one thought to add, which is just that it feels like the stakes are higher in a medical application. I mean, like, Maura and I have been part of the use of some machine learning for detecting out of hospital cardiac arrest calls in emergency services calls. And you feel like there's, you know, very real stakes for something like this. There's great benefits that can come of this technology, but you can also waste resources if you send ambulances to the wrong place. So I think my take on this is just where you're working with something like medical data, you're obviously working with people that have years of training and experience and everything else. And where we might be, say, machine learning or data science people applying a technology within their field, I think it's really important to work with them on the explainability, because ultimately you still want the humans there to be making final decisions and understanding and trusting and all these kind of aspects that we've been talking about. So I think it just makes it all the more important that you work with the people who have that domain knowledge.
But I think I just add to that, I think the difficulty there is in the application. When you say it has more stakes. The application is what has more stake than deciding if you have a dog picture in your library, for example, because then medical data itself, I mean, actually we are working on some medical data here. It actually comes from lots of different places, including text, because it comes from the notes that the doctors write. And as we know as well, extracting that to get the data is actually a really, really hard problem. So because then there are ambiguity, there are all kind of issues. So medical data can include all kind of data. It can include image data because of X-rays or whatever image can there be. It can include text data. It then include also, vital signs or whatever, right? And it typically is over a period of time as well. So the data itself is quite complicated, but of course the application has a huge stake potentially. And I certainly agree with Michael that a system should be used to assist decision-making, but, the human who has a lot of expertise and a lot of experience has the final say in what's happening.
Thanks, Cecile. Next question, is there a model for XAI that can be applied or overlaid as part of existing AI operating models and governance?
So I put my hand up to answer this, but then I thought about it and thought maybe the others have better perspectives on it anyway. I just thought I had something to say, which was that, look, again, I'm not an expert in this area, but I'm aware that there are, look, what you're talking about here, Rachel, is the idea that we have a black box algorithm, something like the deep neural networks, and can we apply something on top of it to add explainability after the fact? It is possible, and it works to differing amounts in different cases. So some of the things that people do is they take the predictions or classifications coming from these unexplainable algorithms, let's say, and put simpler, more explainable models on top and actually look at using those then for the explainability aspect. And that sometimes works. There's other things you can do. And again, I'm explaining this at just a very high level, where you can look at predictions that come out of it and you can just bombard the neural network with lots and lots of, ask it for lots of predictions, where those predictions are like something that you're interested in, like me, if I put in my own data, and then vary particular parameters, right? To look at things that are somewhat like me, but differ in particular ways, and then look at the predictions that come out of it, and then do a sort of classification where you take that set of predictions that come out of it and the inputs that you provided and kind of look at them together to see what is leading to what. So again, these are sort of methods that attempt to add explainability where you can't directly get it.
Yeah, yes, exactly. These are post hoc methods of adding explainability, where you can either overlay it with something which is then attempting to explain it, although it is not an accurate representation of the model, or you're tweaking the data that comes in and then you're aiming to deduce something explainable from different data that you've put into the model and then looking at the output. So both of these are post hoc, and both of these, they can attempt to explain, but they're not directly explaining how the model is coming with the decision. In order to accurately explain how a model is coming into the decision, you need to plan for explainability in the beginning when you are coming up with the model, by choosing those features, by choosing specific, epochs and errors and all of that. It's very, very difficult. Right now, most approaches do post hoc explanations.
Thanks, Moore. Actually, staying with you, might want to pick up on this next question as well, too. In what ways can XAI be informed by naive users? How can we create best practices with feedback from everyday users of AI, not just programmers, designers, practitioners, etc.?
Yeah, beautiful. I love that question. And I think that it's not only in what ways can explainable AI be informed by naive users, but explainable AI must be informed by naive users. I can give an example. For example, right now we're working on, one of my projects is to see how explainable AI is adopted, and how it affects people in old care facilities, older citizens living in or residing in these facilities and their uptake and adaptation of explainable AI. And it's the thing is that they are not considered when these things are being designed. Hence, they do not tailor to their specific needs. So one of the approaches that is being suggested is an approach of co-design. So when you are attempting to come up with a solution to an existing problem, you have to co-design initially with the end users. You have to talk to them. You have to see what they want and how they want it. And then you have to trial it and come back and do user studies. And right now, even if there has been some consultation at the beginning as to what the problem is, they come up with the solution. They say, here you go. And it's not like that. You need to have an interaction. You need to go back and forth. You need to try. You need to talk to the end users. And I think that's something that hopefully we're moving more towards. But yeah, I really like that question. It's important. It's an important fact that we need to consider.
All right, we'll take two final questions briefly because we're just up against the clock as always. From Rachel, I like this question because I think it's really relevant and everybody will be able to identify with it. How do you encourage humans, for example, clinicians in medical imaging, to help train and test the AI when there is the fear barrier that the AI may replace them or affect employment in their industry?
I think if I may then, Andrew, take that one. I think it follows very much from what Moore said before, is you have to engage people from the beginning and actually try to understand in which way can the AI really support them, not replace them, support them, help them in the task which, where the AI can be really good. I mean, the AI can find patterns in data, in millions of data points that, much harder potentially for a user. So if you really work with people, and that's one of the things we are actually looking at in this program I mentioned of collaborative intelligence, is really explaining to the expert, like clinician, that they have expertise and experience which is very, very valued, and it might not be replaceable by AI. AI has other capability that can really support the human. So really engaging, which goes back to what Moore said, sure, it's true for end users, like everybody users, but also experts like clinicians, work with them from the beginning to understand, in fact, where is the appropriate place for the AI in their workflow. Because it may not be to do what we would think without talking to them, we can do X, whatever X might be. No, this is maybe something that the clinician can do better. But we can take aspect of that task, have the AI do the work, and some of the work, and potentially, in fact, maybe not do all of the work, but come up with hypotheses, come up with patterns, present that to the clinician, who can then work with that and potentially have a back and forth. So I think it has to be collaborative, and working with the clinician then is the appropriate way to go. Moore, you have your hands up.
Yeah, I just want to strengthen what you said and also say that I think there's a misconception as well, because people exactly don't know what it means and what AI is. But AI at this point, and I don't really envision a point in the future where it can replace people. And that's not the point. And when we did our research with aged care facilities, we saw a lot of fear in the staff that it could replace them, but also a fear that it would actually add a lot of work, because now we need to learn what to do with this, and we need to change the way we do things in order to kind of maintain this AI thing that they're adding to us. And we don't want to do that. We're overworked as it is. So there's a misconception about what AI is supposed to do for you. And this is, again, as Cecile mentioned, it goes back to the fact that people are not, everyday users are not incorporated in the decision process. And that's a key thing. So co-design and talking and multidisciplinary work should be the answer.
Thanks, Moore. Unfortunately, we're almost out of time, and thanks for some really great responses. I'm sorry we haven't been able to get to all of the questions. Clearly, lots of interest in this topic, and it's certainly one that we could discuss for a lot longer. But can I just conclude by inviting each of our panelists perhaps to give us a concluding thought or a prediction they'd like to make about XAI, or perhaps a difficult problem that you hope XAI might be able to solve in the future. Michael, could we start with you?
Sure. I mean, I guess I would just want to reinforce the same things that Moore and Cecile have said, which is that this needs to be have humans in the loop, have the design of explainable AI happen with that intention from the beginning, rather than being retrofitted, because that really doesn't work. And having both like human-computer interaction experts involved in the teams, not just having isolated teams in machine learning, but also having domain experts involved in this. And I mean, for one moment, I want to touch on one of the questions that Lakshmi has, which is one of this issue of keeping tabs on data supplied to models. I think one of the things we're going to need to see over the next couple of years is about regulation of this, both the things that Cecile mentioned, but with things like GDPR, this European regulations that Cecile was mentioning. I mean, you have a right to be able to request from anyone what information is stored about you. And a lot of people originally saw this as being quite annoying if you're a business and you're having to provide this information and have mechanisms and processes to give it. But I think we're seeing it's going to be really important to understand what information is kept about you and how it's being used.
Thanks, Michael. Moore.
Oh, Michael answered that so well. What Michael said, but no. So I don't have a prediction per se. I have a wishful thinking, which is I hope that in future there will be a move towards incorporating deep learning models with rule-based programming. So I hope that's the future. I hope that's a way to make these models inherently more explainable, while also leveraging the power of these deep learning, models and networks. And so that's my hope / prediction for the future.
Thanks, Moore. And Cecile, final word.
Thank you. Well, I really like what both Moore and Michael said. I think the only thing I will add is actually lots and lots of challenges. I'm not going to make a prediction. I hope in the future, indeed, my wishful thinking is that we do get to a system which, make it clear what they're doing so that we can understand better when they get it wrong, when they get it right. We don't, people don't end up over trusting, etc. But there are a lot of challenges to address. And so it's not a solve. I know we've talked a lot about explainable AI in recent past, but it's nowhere close to being solved. There are lots of challenges. And I hope that what Moore and Michael said also before, of we are inclusive in how we study those issues, because we do need multidisciplinary approaches to all of that. We're not going to solve it. No discipline will solve it on its own. So, and also including users. So I think that's really important. And there, as I said, there are lots of very interesting challenges, but there are lots of challenges in that domain.
Yes, indeed. Thanks, Cecile. My sense is that we really are only embarking on this journey, and there's going to be a lot more to come. I suspect we could be running these seminars every 6 months with the updates and the progress that will be occurring. Well, that brings us to the end of this webinar. On your behalf, can I thank our three panelists sincerely and give them a virtual round of applause and acknowledge the contribution that they've made, and say how much we have enjoyed this discussion, particularly all the insights that they've been able to bring, and to give us some real depth to this discussion as well too. I'd also like to acknowledge and thank the team at Monash for organising today's event. I'm Andrew Patterson. Thanks for your participation today. I hope you've gained a new understanding of this fascinating field, explainable AI, or XAI as we've referred to it. I know I certainly have, and we look forward to seeing you again. A very good afternoon to you all.